So today I'll be presenting on sleep. This is the free dictionary definition of sleep. It's basically a natural periodic state of rest for the mind and the body. Sleep is a topic that I'm really fond of, so it's the topic that I chose for today. So to start, I'll just give a quick overview. We'll first talk about the value of sleep and how it affects almost every system in our bodies. Then we will briefly discuss just sleep neurobiology and the different sleep stages. Then moving on to sleep and brain reset, as well as sleep and its relation to Alzheimer's disease. And then also I'll finish off with a few tips on sleeping. So sleep, for the value of sleep, sleep is when growth hormone is released so that our bodies can maintain themselves and also repair muscle and decrease belly fat. Sleep is also when it helps you consolidate your memory. So this is really important when you had a long day of just learning a bunch of new lessons. It's really important to prioritize your sleep. It's also crucial to know that when your sleep suffers, you suffer major consequences that go beyond the dark circles like under our eyes. What happens is that number one, your level of cortisol is much higher, which makes you eat more. It makes you store belly fat. Your thyroid also takes a hit and it slows down. It also increases your risk of diabetes since your insulin just doesn't work as well. It also increases your risk of metabolic syndrome and heart diseases, cardiovascular diseases. So, but if you do improve your sleep, then you'll likely experience the following benefits. You'll have emotional regeneration, lower levels of inflammation, hormonal balance, as well as faster rate of weight loss. So there was actually a study published in the Canadian Medical Association Journal that showed that sleep deprivation is directly related to the inability of people to lose weight. You're also going to experience longevity, decreased risks of stroke, cardiovascular disease, decreased risk of Alzheimer, cognitive decline. We'll discuss all of this further in the following slides. So this is an image of the brain, and then we see the hypothalamus. Here I'm just going to talk about us being awake and how that's maintained. So wakefulness is maintained by the combined excitatory influences. First of all, of the noradrenergic that comes from right here, the locus coeruleus, as well as histaminergic from the tubulomammillary nucleus. So histaminergic makes sense because when you're taking antihistamine, one of the side effects is drowsiness. Then serotonergic as well from the dorsal raphe, and cholinergic, which isn't shown in this picture. Then over here, you also have the pineal gland, which is where it's located in the epithalamus, and this is where our melatonin is produced, which plays a big role in sleep. In this image, we're gonna discuss now just how sleep is maintained and initiated. So over here in the preoptic area, it maintains sleep mostly in the ventrolateral and the median preoptic nucleus. Then we also have here in the lateral hypothalamus, we have orexin neurons, which are also called hypocretin. And these they reinforce basically arousal pathways in your brainstem. And it also stabilizes both sleep and wakefulness. And then right here in the suprachiasmatic nucleus, this determines basically the timing of your sleep and wake cycle. So now we're going to move on to stages of sleep. Sleep is divided basically into two independent stages. Most people know it's non-REM and REM, REM standing for rapid eye movement. In 2007, the American Academy of Sleep Medicine Task Force basically modified the non-REM sleep stages into 3 stages, N1, N2, and N3. Previously, in their 1968 criteria, RNK, they divided non-REM sleep into stages 1, 2, 3, and 4. But now it's N1, N2, and N3. So here you could just see you're awake, then light sleep, then deep sleep, and then REM sleep. But we'll talk about this further. So this picture explains it pretty well. We'll go through the sleep stages. So for N1, it's when you're basically falling asleep, when your eyes are closed and you're just relaxing. Your breathing becomes more shallow, your blood pressure falls, and your muscles just begin to relax. Then we move on to stage N2, which is your light sleep. A unique feature here includes like sleep spindles on the EEG and biphasic K complexes, which I'll show. Your body temperature drops. There's a diminution of most physiological bodily functions. Then we move on to N3. This is the most restorative form of sleep that we have. Also, disorders such as sleep terror or somnambulism are most common in this sleep stage. And I'll show in the EEG recordings. You see a lot of delta rhythms at this stage of sleep. And as well, this is when tissue repair happens and growth, as well as cell regeneration and your immune system strengthens. So moving on to REM sleep. REM, it's when you have conjugate, irregular, sharply peaked movement. On EEG, you could see here some beta rhythms. As well, sometimes you could see a sawtooth appearance when you're looking here. At this point of sleep, it's when your physiological activity is higher. Your blood pressure could increase, or you could have fluctuations. Your breathing becomes irregular, and you can also see increased oxygen consumption in the brain. If you were to wake somebody up when they were in REM sleep, you would see that most of them are able to recall their dreams. At this point, also, if you have a short REM sleep latency, it could point to either cumulative sleep deprivation, or it could show like an acute sleep disorder. And then here is just the EEG recording for all the different, you see the sleep spindles and the K complexes in the stage 2. So now we're going to move on to sleep and brain reset. So generally when you're awake, that's a catabolic, which means like breaks you down. And when you're awake, when you're asleep, it's anabolic, so builds you up. There was research that actually showed that after 24 hours of sleep deprivation, there was an overall reduction of 6% in glucose reaching your brain. So a simple translation for this is when you're sleep deprived, you become a less smart version of yourself. So as Dr. Charles, he's a professor of sleep medicine at Harvard Medical School, stated in one of his studies that the negative effect on cognitive performance can be similar to those that occur after drinking too much alcohol. So now we already know that after 24 hours without sleep, or if you have a week, like you're studying too much that week, and you have a week where you're only sleeping 4 to 5 hours per night, it induces an impairment that's equal to having a blood alcohol level of 0.1%, just because you're not sleeping well. There was also a study that was published by the American Academy of Sleep Medicine, and they found that poor sleep activity was basically equal to binge drinking alcohol and marijuana use in determining academic performance. So this just shows how important it is for cognitive performance and academic performance to really prioritize your sleep. So the most important, like the most valuable takeaway from this sleep deprivation discovery and all the studies that were done on it is that the reduction in the glucose is not equally shared all like around your brain. So you know when sometimes you're up past your bedtime, let's say your bedtime is like 10, you're up at 12 a.m. because you're studying, and you just laugh at things that aren't funny, or you do things that you wouldn't usually do. So there's an explanation for that. It's basically because your parietal lobe and your prefrontal cortex actually loses 12 to 14% of their glucose when you don't sleep, when you're sleep deprived. And these are the areas of the brain that we need the most for thinking, for distinguishing between ideas, for social control, and for also just being able to tell the difference between what's right and wrong. And those are the areas that suffer when you're sleep deprived. So to continue with the same topic, scientists have found that the brain has its own unique waste disposal system, which I think most of you guys know. It's similar to that of the lymphatic system. It's called glymphatic system, with the added G as just a special shout out for the glial cells in the brain that control it. So during sleep, the lymphatic system becomes 10 times more active than when you're awake. So simultaneously, the brain cells decrease in size from about 60%, so that while you're asleep, waste removal is even more efficient. So, no, yeah. So because when you're awake, you're doing a lot of things, you're learning, you're developing, your brain is continuously building up a lot of byproducts, and these are mainly removed by the restorative power of sleep. So let's say if at home, your waste is just building up, it's gonna get messy really quick in your house. And it's the same thing that happens when you're not sleeping well. Your lymphatic system just cannot do its job as well as it would do if you're having the sort of power of sleep. And basically there was a study that was done and they saw, which I'll talk about on the next slide, that the inability of your brain to even remove these harmful waste products is believed to be one of the foundational causes of Alzheimer's. So here in this study, there was in a study comparing awake mice and then mice that were asleep either physiologically or sleep induced with anesthesia. They found, Z and his colleagues found that the AB protein was eliminated more efficiently, actually twice the speed during physiological sleep than in being awake. And based on these results, basically the researchers started focusing their attention on this mechanism that was linking sleep and just the metabolic clearance of these byproducts and Alzheimer's disease, even though this has received some contrary, contrary opinions. Some people are saying that no, it's not, but there's a lot of studies now on this. So now this is my favorite part. It's just a few tips on how we can all sleep smarter. And it's things that maybe some of you guys already know. Number one, it's to get more sunlight during the day. So this is important because to support your circadian timing system and just the rhythm. And also it's important with your hormones when they're getting released, just to get sunlight during the morning. And your body clock is more responsive to sunlight if you can get it around 6 a.m. to 8:30 a.m. If you could just go outside, like obviously don't look at the sun directly, but if you can get that sunlight, this will really help to readjust all of our circadian rhythms. Number two, this one is like a little bit hard to do, even like for students and things like that. If you have to study before bedtime, it's understandable. There's other things that we can do, but it's preferred if you could stop 90 minutes before bedtime, just so you could give your body that deep sleep that it needs. If you're unable to do that, if you have to study or do something on your computer, what you could do is just get a blue light blocker, even on your smartphone and whatnot, because there's a lot of blue light emanated from our screens. If you could get that orange cue, it would really help. Another thing is to have a caffeine curfew. This is also really hard to do. But generally for most people, if you could stop caffeine before 2 p.m., it would be preferred. Since caffeine actually has a half-life of around 5 to 8 hours, depending on your own physiological makeup, it takes a really long time for it to be fully out. Even there was a study that was done, even if you don't know that your sleep is affected, people that have caffeine later in the day, they lose that restorative sleep, the stage 3 that we talked about, N3. So it's important to try to limit caffeine. Another tip, be cool. Basically, there were studies done that found that the optimal room temperature for sleep is actually quite cool, around 60 to 68 Fahrenheit. And they saw that insomniacs actually had a higher body temperature. That's why, like, if it's kind of hot, you'd be rolling around the bed and things like that. So try to put your room in a cooler temperature. Another really important thing is to go to bed at the right time. So it's been shown that us human beings, we get the most beneficial hormonal secretion and recovery by sleeping during the hours of 10 p.m. to 2 a.m. So these hours are the most restorative for us. And then there's a fun fact with this. There was the International Agency for Research on Cancer. They now classify overnight shifts as a group 2 carcinogen. So there was actually, they did a study with women who were working overnight, and they saw that these women had, I didn't include the study, but it's in my references, that these women had an increased rate of breast cancer. And they did other studies too. So now they rate overnight shift as basically a group 2A carcinogen. Yeah. And that's it. That's it for my research, for my presentation. I hope that it was useful and that there's some value in it. These are my references. And yeah, that's it. Thank you for listening.